and today's topic is writing and balancing chemical equations. We're not going to go into how we classify the equations in this. I'll mention that as we go along, but that's not the intent of this video. We're just going to look at how we write and balance equations. And these first two that you can see on the screen here are word equations, and they're only the first half. The first one here is a double replacement reaction. And what you need to be aware of on a double replacement, that these are ionic compounds, and that ionic compounds have positive and negative ions. And so when you make the products out of these, you still need each compound in the products also need to be a positive and a negative ion. So we wouldn't put the sodium with the barium, we would put the sodium with the hydroxide and the barium with the sulfate. So I like to have my students, when they start out in words, complete the reaction in words. So sodium hydroxide and barium sulfate. So you are probably aware, well, the charges aren't going to change from one side to the other. So the sodium and the hydroxide and the barium and the sulfate. Sodium, of course, is a positive 1 charge. If you remember from our previous discussions, sodium is a positive 1. Sulfate over here is a -2 ion. Barium is here in the +2 column. And hydroxide is a -1. They're not going to change from one side to the other. And so we've got the charges all figured out. Now what we need to do is write the formulas for each of these 4 compounds. And what tends to cause people problems is they try to balance the equation while they're writing the equation. So you've got to have the formulas correct for each compound before you can even begin to think you're going to get the equation balanced correctly. So we need to remember our rules for writing formulas. And for sodium sulfate, since the sulfate has a -2, the sodium is a +1, I'm going to need 2 sodium ions to balance the -2 sulfate ion. So I'm going to write Na2SO4. And then I'm going to ignore that completely. I'm going to look only at the barium hydroxide. The barium's +2, hydroxide -1. I'm going to need 2 hydroxides to balance the +2 from the barium. Now be aware that the hydroxide, we need 2 hydroxide ions, not just 2 hydrogen atoms. Be aware that OH2 is not the same as 2 OHs, right? We've got 1 O and 2 H's. Here we've got 2 O's and 2 H's. So it does make a difference. You need to be vigilant on your parentheses where they're needed. All right, now here's where it gets a little more complicated. We don't want to take the 2 from the sodium and the 2 from the hydroxide when we're writing sodium hydroxide, because that doesn't make sense. We need to just look at sodium hydroxide. It's +1 and -1. NaOH is the formula for sodium hydroxide. And likewise with the barium sulfate, let's not look at anything else, just the barium sulfate, +2, -2, BaSO4. Now I've got all my formulas correct. I'm ready to balance the equation. And there are different ways to do it. Some people will just look at this and know what they need to do immediately, and others it takes a little more work. So what I like to do on a problem like this is I'm going to notice that the sulfate, the SO4, stays as sulfate on the opposite side of the equation. There's no sulfur anywhere else in the problem except for in these 2. And similarly, the hydroxide doesn't change from one side to the other. So when I'm making what I like to call my atom inventory, I'm going to keep the sulfate ions and the hydroxide ions as a unit. So how many sodiums do I have? I have 2. How many sulfates? I have 1. How many bariums? 1. How many hydroxides? 2. I like to list them in the same order on both sides of the equation, just so I'm comparing the same thing on each side. I've got 1 sodium, 1 hydroxide, 1 barium, and 1 sulfate. Now you can clearly see that the sodium and the hydroxide are out of balance in this equation. There are 2 here, but there's only 1 here, 2, only 1. So I need to double somehow my sodium and my hydroxide. I can't put subscripts in here because this formula is correct as it's written. We made a point of that earlier. So I have to put a 2 out front, which will change my sodium to a 2 and my hydroxide to a 2. And now you'll notice 2, 1, 1, 2. This equation is balanced. I am done with that problem. The second one is a single replacement type reaction. We have silver nitrate, which silver is a +1, nitrate is a -1. Okay. So it's, oh, I'll go ahead and write the other side. I forgot that. So the aluminum, being a metal, will replace the metal in the compound. And there are some rules that go along with that that you learned when you were learning about the different types of reactions. So the aluminum might replace the silver. If it does, we'll have aluminum nitrate plus silver. When you see just aluminum or just silver, those are metallic elements, elemental aluminum, elemental silver, which means the aluminum is Al and the silver is Ag. Silver nitrate is a compound, an ionic compound. Ag +1, NO3 is a -1. I just need one of each. Aluminum, you might remember, is in the +3 column of the table. Nitrate, again, is -1. So I'm going to need 3 nitrates to balance the aluminum. Al3, 3. This 3 is part of the nitrate. This 3 tells me I've got 3 nitrates. So don't make that an NO9 or anything like that. Or just ignore this 3 because there's already a 3 there. So we're ready to balance this equation. Again, the nitrate does not change. It stays nitrate on both sides. Oops, Ag, NO3, and Al. I have 1 Ag, 1 NO3, 1 Al, 1 Ag, 1 Al, 3 NO3s. Now the only way I can get 3 NO3s on this side is to put a 3 out front. I can't change this. This formula is correct as written. If I do anything to that with a subscript or a number out front, I have to go clear out to the beginning of the formula, which is going to change my silver to a 3 also. Now the silver was 1, but now it's 3. So I just need to put a 3 there. And I've got that equation balanced. This next equation, next reaction, is a combustion reaction, hydrocarbon combustion. It's carbon and hydrogen plus oxygen. The products of this reaction are always CO2 plus H2O. Any carbon-hydrogen containing compound plus oxygen, which is combustion, always makes carbon dioxide and water. I have 2 carbons. I have 4 hydrogens. I have 2 oxygens on the left. I've got 1 carbon. I've got 2 hydrogens. I've got 3 oxygens. 2 plus the 1 is 3 on the right. If I will balance my carbons first, I'll need a 2 to make the carbon both 2. Now my oxygens in this case, 2 times 2 would be 4, plus the 1 there. So now I've got 5 O's on this side. I need to balance my H's. I've got 4 on the left. I need a 2 here. That'll make that a 4. Now this will be 4 O's plus 2 more. 6 oxygens on this side. 2, 4, 6 O's, only 2 O's. So I need a 3 here, which will make that a 6. And that equation is balanced. This next one is a double replacement. It's different than the other page because I didn't write the words out. I just gave you the beginning of the equation. But again, the zinc being a +2, the chloride being a -1. Since this nitrate, since there are 2 of them, and nitrate is -1, this must be a +2 lead and a -1 nitrate. So the zinc and the lead, being both positive, need to swap. They will trade partners. So instead of zinc chloride, we'll have zinc nitrate. And again, the zinc being a +2, the nitrate being a -1, I'm going to need 2 nitrates. And then lead with the chlorine, PbCl. The lead here was +2. It will be +2 on this side also. The chloride is a -1. I'm going to need 2 chlorides. So these formulas are correct. We don't keep those charges on there because these are neutral compounds. We've now got the formulas correct, and if we're ready to balance, we've got 1 zinc, 2 chlorines, 1 lead, 2 nitrates, 1 zinc, 2 chlorides, 1 lead, 2 nitrates. Notice 1, 2, 1, 2. This equation is already balanced. And finally, the last equation I have for you today is the decomposition reaction of calcium chlorate. Now, you may or may not know this is a special decomposition. Metallic chlorates decompose into metallic chlorides and oxygen gas. Metallic chlorate makes a metallic chloride and oxygen. So calcium being a metal, it's on the metal side of the table. There it is, calcium. I know you think of milk when you think of calcium, or bone, but it's a metal. Calcium has a +2 charge. The chlorate is -1, that's why there are 2. So calcium chlorate will make calcium chloride. Now, why is it Cl2? Well, the calcium is a +2. The chloride is -1. I need 2 chlorides to cancel out the +2 from the calcium. And oxygen. Oxygen, here's something else we need to do. Something I do right away at the beginning of school when I hand out my periodic tables is we circle 7 elements. And it's not random. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. I have my students circle those because those are called diatomic elements, which means when they are not in a compound, when they are not an ion, when they're in their elemental form, they're in pairs. You never have just hydrogen atoms. It's H2. You could have hydrogen ion, you can have hydride ion, but you never have hydrogen atoms by themselves. It could be a transition in a chemical mechanism at some point, but we're way not ready for that yet. So just be aware, hydrogen will always be H2, nitrogen will be N2, O2, F2, Cl2, Br2, I2 when they're by themselves. So it's O2. All right, so let's make our atom inventory. Now I'm busting up my chlorate ion this time because it doesn't stay the same on both sides. 1 calcium, 2 chlorines, 6 oxygens, 1 calcium, 2 chlorines, 2 oxygens. All right, the calcium looks good, the chlorine looks good, only the oxygen is a problem. We've got 6 on the left, we only have 2 on the right. What can I do to the O?